Hello, my name's Clinton and I'll be your guide through this second module of Day 2. We're going to talk some more about linear functions. Please don't forget to pause this presentation at any time if you need more time to think about something. In this module, we're going to see how to find equations of lines when we're given other information. If we know the gradient of a line, and the coordinates of some point on the line, then this is actually enough to work out its equation. Let's see how to do this. By way of an example, let's think about the line which has gradient 2, and which we know passes through the point -1, 2. So the x-coordinate of the point is -1, and its y-coordinate is 2. The gradient m is 2, so if we write the equation in the form y equals mx plus b, the line must have the equation y equals 2x plus b for some number b, since m is 2. But we haven't yet used all of the available information. Since we know -1, 2 lies on the line, this point must satisfy the equation. So we must have 2 equals 2 times -1 plus b. We can now solve this equation and find the value of b. Moving the -2 onto the left-hand side gives b equals 2 plus 2 is 4. Hence the equation of our line is y equals 2x plus 4, with m equals 2 and b equals 4. Here's the graph of the function. We can draw it by starting at the point we were given, -1, 2, and drawing the line with gradient 2. Alternatively, we could find the coordinates of another point on the line, say by setting x equals 0 and seeing that y must be 4, and then drawing the line joining these points and extending it in both directions. Now pause and try these practice questions yourself. Press play when you want to continue. Here are the answers. Press pause and then play when you want to continue. If we're given 2 points, let's call them x1, y1 and x2, y2, which lie on a line, we can use the rise over run formula to compute the gradient. We need to work out the change in y, which is the difference y2 minus y1 between the two y values, and the change in x, which is the difference x2 minus x1 between the two x values, and then calculate the ratio. This will make more sense when we see an example. Here's a summary of the approach we're about to use. We'll first use the rise over run formula to find the gradient, and then, since we know m, we can substitute one of the 2 points we know into our equation, y equals mx plus b, to find b, just like we did before. So let's find the equation of the straight line which joins the 2 points -1, 2 and 1, 3. Using the rise over run formula, the change in y is 2 minus 3 equals -1. Just subtract the two y values. And the change in x is -1 minus 1, which is -2. Again, just subtract the two x values. So the gradient is -1 divided by -2, which is 1/2. We can now use one of the points, let's use 1, 3, to find the equation. Since we know the gradient is 1/2, the equation will be y equals 1/2x plus b for some number b. We know 1, 3 must satisfy the equation, so we must have 3 equals 1/2 times 1 plus b, since 3 is the y value and 1 is the x value. Rearranging this equation gives b equals 3 minus 1/2 equals 2.5, or 5/2. So the equation of our line is y equals 1/2x plus 5/2. That is, m equals 1/2 and b equals 5/2. It shouldn't matter which point of the two we are given we choose to work out b. Check that you get the same equation if you use the other point, -1, 2. Press pause, and then press play when you're ready to continue. Let's do something a little different now, and try to sketch the graph of a linear function, given its equation. In order to sketch the graph, we need to just find 2 points on the line. Then we can join them together with a straight line and extend it infinitely in both directions. 2 points which are especially simple to find are the x and y intercepts. The x-intercept is the point where the line crosses the x-axis. We find this by setting y equals 0, since y equals 0 along the x-axis. Similarly, the y-intercept is the point where the line crosses the y-axis, and we find this by setting x equals 0, since x equals 0 along the y-axis. This can be a bit confusing, but don't worry. Once you've done a few examples, you'll get the hang of it. Let's have a look at an example now. This time, we're given the equation in the form ax plus by plus c equals 0, with a equals 1, b equals 2, and c equals minus 4. We find the x-intercept by setting y equals 0. This gives x minus 4 is 0, so x is 4. Similarly, we find the y-intercept by setting x equals 0. This gives 2y minus 4 is 0, or 2y is 4, so dividing by 2, we get y equals 2. Here's the x-intercept. The graph hits the x-axis at x equals 4. And here's the y-intercept. The graph hits the y-axis at y equals 2. It's now easy to draw the line 2y plus x minus 4 equals 0.